96% of Egypt is desert. 110 million people survive on a narrow ribbon of green land along the Nile River, a ribbon that makes up less than 5% of the entire country. And that ribbon is running out of space to feed a nation that grows by 2 million mouths every single year. For 5,000 years, Egyptians have been prisoners of geography, surrounded by the Sahara Desert, the largest hot desert on Earth, trapped along the Nile, the only source of water in a land where rain almost never falls. Every farm, every city, every life depends on one single river, and that river is no longer enough. The crisis is not coming, it is already here. Egypt imports over half of its wheat, the staple food of its population. Arable land per person has dropped to among the lowest on Earth, and upstream Ethiopia has built the Grand Renaissance Dam, threatening to reduce the Nile's flow into Egypt by as much as 25%. The math is terrifying. More people, less water, shrinking farmland. A nation of 110 million people facing the very real possibility that within decades there will not be enough food or water to sustain its own population. Egypt needed a solution so bold it would rewrite the geography of an entire country. In 2021, the Egyptian government launched the New Delta Project, a mega infrastructure program with a total investment exceeding $10 billion United States dollars. The goal was staggering: build a massive artificial river system to carry Nile water deep into the western desert and create an entirely new agricultural region from nothing but sand. This was not a modest irrigation project. This was an attempt to build a second Nile Delta, a man-made network of canals, pipelines, pumping stations, and reservoirs stretching over 170 kilometers across some of the most brutal desert terrain on Earth. Egypt was going to force the desert to produce food. The project centered on the El Hamam Canal, a massive concrete channel designed to carry millions of cubic meters of water from the western branch of the Nile across the desert toward the Mediterranean coast. This single canal would become the lifeline for over 200,000 hectares of new farmland carved from the Sahara. But building a river through the Sahara Desert presents engineering challenges that would terrify construction teams anywhere on Earth. Daytime temperatures regularly exceed 45 degrees Celsius. Sandstorms can strike without warning. The ground is unstable, shifting sand that absorbs water like a sponge. Nothing about this environment wants to cooperate with human ambition. The Egyptian government mobilized a construction force of over 12,000 workers. Hundreds of excavators, bulldozers, dump trucks, and specialized machines were deployed across the desert. The operation ran 24 hours a day, 7 days a week, with crews working in rotating shifts under conditions that pushed human endurance to its absolute breaking point. Before digging could begin, the desert floor had to be prepared. Hundreds of bulldozers attacked the sand dunes, cutting down ridges and flattening the terrain. The goal was creating a smooth, stable surface that could support the weight of heavy construction equipment without collapsing beneath it. Every meter of surface was graded and compacted under strict engineering supervision. Survey teams using GPS systems accurate to within centimeters mapped the entire route. The canal alignment had to follow a precise gradient, dropping just 1 centimeter for every 10 meters of distance. This impossibly gentle slope would allow water to flow by gravity alone without requiring continuous pumping. Precision measured in millimeters across 170 kilometers. The excavation phase was enormous. Massive excavators carved the canal profile into the desert floor, creating a wide U-shaped channel approximately 45 meters across at the top and 7 meters deep. Every day, approximately 70,000 tons of sand and rock were removed from the construction corridor and relocated to form protective embankments along both sides. Over 1,200 engineers and operators worked in rotating shifts, enduring temperatures that regularly exceeded 45 degrees Celsius. Medical teams stood on constant standby, treating heat exhaustion and dehydration cases daily. Water trucks circulated continuously through the work zones. Yet the digging never stopped. Not for heat, not for sandstorms, not for anything. The excavated sand was not wasted. It was compacted into embankment walls rising 3 to 5 meters above the canal edges on both sides. These levees would protect the canal from wind-blown sand and contain the water during peak flow periods. In areas with weak soil, engineers drilled cement stabilization columns up to 8 meters deep to prevent future settlement. The most critical phase was waterproofing. The Sahara sand can absorb millions of liters of water within hours. If the canal bed was not perfectly sealed, the entire project would fail. Billions of precious Nile water simply vanish into the desert floor. Billions of dollars dissolving into sand. This phase had zero margin for error. First, a precise layer of fine sand, 50 millimeters thick, was spread across the entire canal bed, creating a smooth, uniform foundation. Then, concrete panels, 120 millimeters thick, were cast in sections measuring 5 meters by 3 meters. Between each panel, expansion joints were filled with hot bitumen sealant to prevent cracking from the desert temperature extremes. Beneath the concrete, an additional layer of high-density polyethylene geomembrane was installed. This waterproof sheet was anchored with steel pins driven into the ground and protected by a sand cushion above. The multi-layer system created a barrier so impenetrable that independent testing confirmed less than 0.1% water loss through the entire lined canal system. Over 124 kilometers of canal were sealed with this waterproofing system. It became one of the largest continuous waterproofing installations ever completed in North Africa. Along the embankment slopes, engineers planted vetiver grass and drought-resistant vegetation to stabilize the soil surface and prevent wind erosion from depositing sand back into the channel. At strategic intervals along the canal, engineers constructed regulating reservoirs. These wide, shallow basins, each covering approximately 2 hectares, served as hydraulic buffers. They absorbed flow fluctuations from the main canal, preventing surges that could damage downstream infrastructure. Each reservoir was lined with waterproof membrane and concrete panels identical to the main canal system. Water control weirs were built at critical junctures along the route. These massive reinforced concrete structures contained steel gates that could be raised or lowered to precisely regulate water flow. Each gate was controlled by hydraulic systems connected to a central monitoring network, allowing operators to adjust flow remotely based on real-time demand from downstream agricultural zones. The distribution system beyond the main canal was engineered with equal precision. Large-diameter steel pipelines ranging from 1.5 to 3 meters across were fabricated in modules and transported to the desert site. Trenches were excavated to precise depths, ensuring the pipes would deliver water by gravity alone, without requiring energy-intensive pumping at every branch point. Each pipe section was lowered into its trench by heavy cranes, aligned with laser-guided instruments, and welded using full-circumference automated welding systems. Every single weld was inspected using ultrasonic testing to detect microscopic defects invisible to the human eye. A single failed weld in a pressurized waterline beneath the desert could cause catastrophic failure. Once installed, the pipelines were bedded in fine sand cushioning to protect against ground settlement. Then the trenches were backfilled in compacted layers. Hundreds of kilometers of buried pipeline now carry water silently beneath the desert surface, delivering it to distribution points across the new agricultural region, an invisible underground river feeding life to lifeless land. At the upstream end of the entire system sits the heart of the project, the El Hamam pumping station. This massive facility draws water directly from the Nile through deep intake structures designed to function even when river levels fluctuate seasonally. High-capacity submersible pumps push millions of cubic meters of water into the canal system daily. Each pump unit is controlled by variable frequency drives that adjust motor speed in real time based on system demand. Water level sensors, pressure transducers, and flow meters throughout the network continuously transmit data to a central control room. The entire system operates with intelligent automation, optimizing water distribution while minimizing energy consumption across the complete network. The smart water management system represents a technological leap for Egyptian infrastructure. Satellite monitoring tracks water distribution across the entire project area. Soil moisture sensors embedded in agricultural zones report real-time conditions directly to the control system. Water delivery is adjusted automatically, ensuring every hectare receives precisely the amount needed, not a drop more, not a drop less. When the control gates were opened for the first time and Nile water began flowing through the completed canal system, the transformation was almost immediate. Water filled the regulating reservoirs, passed through the control weirs, and advanced through the pipeline network into areas that had not seen moisture in thousands of years. The desert began to change. Center pivot irrigation systems were installed across the newly watered land. These massive mechanical structures rotate slowly around fixed points like enormous clock hands. Each system covers a circular area up to 800 meters in diameter, distributing water evenly through sprinkler heads. From satellites, the desert floor suddenly showed enormous green circles appearing where only sand had existed before. The visual transformation is extraordinary. Satellite imagery shows the western desert dotted with bright green circles where the irrigation systems operate. Each circle represents productive farmland growing wheat, barley, vegetables, and fruits on land that 12 months earlier was completely barren sand. The desert is literally turning green in real time, visible from space. Over 200,000 hectares of new farmland are being developed across the project area. This represents a massive expansion of Egypt's total agricultural capacity. Crops that were previously imported at enormous cost are now being grown domestically. The project directly addresses the food security crisis that threatens the nation's future stability and independence. But the new Delca project extends beyond crop farming. Alongside the agricultural zones, large-scale livestock operations have been established on the newly reclaimed land. Industrial cattle farming complexes, each housing up to 6,000 animals, have been constructed using prefabricated steel structures with climate-adapted designs featuring natural ventilation and sun shading systems. The livestock operations are integrated with the surrounding cropland. Feed for cattle is grown on adjacent irrigated fields. Water for the animals comes from the same canal network. Waste from the livestock operations is processed and returned to the fields as organic fertilizer. Every element feeds back into the system, creating sustainable circular agriculture. The economic impact is already measurable. Thousands of permanent agricultural jobs have been created in regions that previously had zero economic activity. Support industries, including equipment maintenance, transportation, processing, and packaging, have developed around the farming zones. Entire new communities are forming in areas that were uninhabitable desert just years ago. Egypt is also developing desert-compatible renewable energy infrastructure alongside the agricultural project. Solar farms positioned near the canal system generate electricity for pumping stations and agricultural processing facilities. The intense Saharan sun that makes the desert so hostile to life is being harnessed as an energy resource to support the very agriculture that is conquering it. But challenges remain significant. The project's reliance on Nile water creates vulnerability. Any reduction in Nile flow, whether from climate change or upstream dam operations, directly threatens the new agricultural zones. Egypt's ongoing diplomatic tensions with Ethiopia over the Grand Renaissance Dam cast a shadow over the long-term water security of the entire new delta system. Environmental scientists raise concerns about the ecological impact of large-scale desert reclamation. Extracting billions of cubic meters of water from the Nile affects downstream ecosystems, including the Mediterranean coastal wetlands that depend on Nile outflow. The balance between agricultural development and environmental preservation remains a subject of active scientific debate. Soil salinity presents another long-term challenge. Irrigation in desert environments inevitably deposits minerals in the soil as water evaporates. Over decades, without proper drainage and soil management, these mineral deposits can accumulate to levels that poison the very farmland the project created. Managing salinity will require continuous investment and engineering attention for generations. Despite these challenges, the scale of achievement is undeniable. Egypt took a desert that had been lifeless for millennia and forced it to produce food for millions of people. It built a river where none existed. It created farmland from sand. It proved that with sufficient engineering ambition and national commitment, even the Sahara Desert can be made to serve human civilization. The ancient Egyptians built pyramids that still stand after 5,000 years. Modern Egyptians are building something equally ambitious, not monuments to death, but infrastructure for life. A man-made river carrying water through the desert, feeding a nation that refuses to be limited by its geography. The pyramids preserved the past. The new delta secures the future. From space, you can see it clearly. Green circles spreading across the golden desert like life itself, advancing into territory that belonged to sand for thousands of years. It is beautiful. It is audacious, and it proves that when a nation's survival depends on engineering, the results can change the face of the earth itself. What do you think about Egypt's man-made river project? Can desert agriculture truly feed a growing nation? Or will water scarcity ultimately limit what engineering can achieve? Share your thoughts in the comments below. And if this story amazed you, hit subscribe and turn on notifications so you never miss another incredible engineering story from this channel.